This is section 16.5 on curl and divergence. So on page 1103. All right, here's a formal definition of curl, but this is not the version that I want you to use. So do not put this on your cheat sheet. I mean, it's true, there's nothing wrong with it. It's a lot more compact if you put it in this fashion. And this is how I want you to work it out as a determinant. Okay, so curl f, vector function f, or del cross f, it's a cross product between del and f. So you have I, j, k, the top. The minimal is always partial with respect to x, y, and z, although you're not really multiplying. Okay, you're just inserting the p, q, and r in their proper places. So if you kind of look at the way it works, you get the hang of it. So the I component is a partial of r with respect to y minus a partial of q with respect to z times I. Notice you're not really multiplying, you're just sticking the r here and going that minus that. Okay, and this one, again, think of it as minus partial of r with respect to x minus a partial of p with respect to z, which is the opposite of this. And that's the way you normally evaluate determinants. And then the k component is that minus that, partial of q with respect to x minus a partial of p with respect to y. Okay, so that's how we would determine something called the curl. Okay, or curl f is del cross f. Okay, so you can put that on your formula sheet. On page 1104, get this thing in focus here. It's a nice theorem. If f is a function of three variables that has continuous second order partials, curl of del f equals the zero vector. To prove it, you actually just do it. So they actually computed this thing and you end up with the zero vector. Okay, and we have by Clairaut's theorem, I can get this thing focused, this nice theorem here. At the bottom, if f is conservative, then curl f is the zero vector. So we talked about a conservative vector field in 2 dimensions. In 3 dimensions, how do we know we have a conservative vector field? If the curl of the vector function f is the zero vector. Okay, and it's converse on page 1105. A little bit. So you can put this on your cheat sheet. If capital F or bold F is a vector field defined on all of R3, whose component functions have continuous partial derivatives, it's going to be true for all the ones that we do. And curl F is a zero vector, then F is a conservative vector field. Okay. So you might recall we had a way of determining that in 2 dimensions. Okay, that was what the partial of q with respect to x had to be equal to the partial of p with respect to y. I'll just mention very quickly. If you look at that, the 2-dimensional flavor. Okay, so the 3-dimensional flavor says this is 0. Okay, that means partial of q with respect to x minus the partial of p with respect to y has to be 0, i.e. partial of q with respect to x equals the partial of p with respect to y. Okay, and each of these, p, q, and r, there is no r, so that's 0. There is no z, so that's 0. Which again, there is no z, so that's 0. There is no r, so that's 0. So you'll get 0, 0, and partial q with respect to x equals the partial p with respect to y. Okay, so this is the more general flavor, the 3-dimensional flavor. And in the 2 dimensions, it means that there is no r and there is no z, which means this is 0, and these two have to be equal, which is exactly the 2-dimensional flavor that we saw before. So I just wanted to mention that in passing. All right, just a very little bit about physics. You'll learn more about this in the physics class. Okay, but just as you might think, the curl is a tendency to curl about an object that we see here. So the reason for the name curl has to do with rotations. Okay, one connection is explained in exercise 37. Another occurs when F represents the velocity field in fluid flow. Particles near X, Y, Z in the fluid tend to rotate about the axis that points in the direction of curl F of X, Y, Z. And the length of this curl is a measure of how quickly the particles move about the axis. So it's a tendency to spin. The curl gives you a tendency to spin about a particular point. Okay, if the curl of F is 0, then we have another word for it called irrotational. So if this comes out to be the 0 vector, there is no tendency to rotate about a particular point. There's no whirlpool or eddy. One of the homework problems uses the word irrotational. Irrotational means curl of F is the 0 vector. All right, then we have the divergence. Okay, so here's a definition of divergence. given a three-dimensional vector PQR. So the divergence is partial P with respect to X plus the partial of Q with respect to Y plus the partial of R with respect to Z. Okay, and another way to think of it is divergence of F is del dot F. So curl is del cross F, div is del dot F. So dot product is usually easier. Again, think of it as partial with respect to X, Y, and Z dot P, Q, R. You're not really multiplying, but you're just sticking in the P, Q, and R right over here. Okay. And we have this theorem. You can put this on your cheat sheet, although there wasn't a whole lot of problems with it. Theorem 11, the divergence of the curl of F is the number 0 because the divergence comes out to be a scalar quantity. So div curl F is equal to the 0 number. And on page 1107, a little bit of physics again. The reason for the name divergence can be understood in the context of fluid flow. If capital F of X, Y is the velocity of a fluid or gas, then div F represents a net rate of change of the mass of the fluid flowing from the point per unit volume. There's a tendency of the fluid to diverge from a point. If divergence of F is 0, then F is said to be incompressible. There is no tendency to spread out, to either spread out or to compress itself as a gas or a fluid. Okay. All right. Okay, so here we go, page 1109. There are some more problems. 11 and 13 to 17, 18, 21. Okay. I think that's all we have to do. All right, so number 1, f of x, y, z is x, y squared, z squared, x squared, y squared, z, and x squared, y squared, z. Okay, so curl is del cross f. The top is always I, J, K. The middle is always partial with respect to x, y, and z. And then P, Q, and R go here. So x, y squared, z squared, x squared, y, z squared. Sorry, this was x squared, y, z squared. I think I wrote it incorrectly there. X squared, y, z squared. And then x squared, y squared, z. Okay, so I component is that minus that. So partial with respect to y is that. Partial with respect to z is that. J component is the opposite of the partial with respect to x is that. Partial with respect to z is that. And then the k component is partial with respect to x is that. Partial with respect to y is that. And they all come out to be 0, so you end up with a 0 vector. Divergence is partial p with respect to x, so y squared, z squared. Partial of q with respect to y was x squared, z squared. And partial of r with respect to z is x squared, y squared. So that's all. Okay, 7, same thing. F is this, that's p, that's q, that's r. So for curl, it's always I, J, K. It's always partial with respect to x, y, and z. And then you just put p, q, and r. E to the x sine y, e to the y sine z, e to the z sine x. Okay, looks like I messed up the first time I did it. But I component is that minus that. Partial with respect to y is 0. Partial with respect to z is e to the y cosine z. Okay, minus that e to the z cosine x minus nothing. And then the k component is that, which is 0, minus e to the x cosine y. So I end up with negative e to the y cosine z, negative e to the z cosine x, negative e to the x cosine y. Divergence is partial p with respect to x, e to the x sine y, plus a partial of this with respect to y, e to the y sine z, plus a partial of this with respect to z, e to the z sine x. And that's all there is to it. All right, then do we or do we not have a conservative vector field? It might actually be easy if I start off with 15. F of x, y, z is this. So del cross f or curl f is partial of I, J, K, partial with respect to x, y, z of z cosine y, x, z sine y, x cosine y. Okay, so this is negative x sine y minus x sine y. It's not 0. Okay, I can stop. I don't have to find out this component or this component. I do not have the 0 vector. So therefore, del cross f is not the 0 vector. So I automatically do not have a conservative vector field. So I'm finished. This one was not 0. So it doesn't matter whether these come out to be 0 or not. The first component, P component, does not come out to be 0. So we do not have a conservative vector field. So we're finished. Okay, how about this one? So set this one up. So that, you're not really multiplying, you're taking the derivative with respect to y. So that's going to be 6x yz squared minus partial with respect to z. This is 6x yz squared, which is a 0 vector. And then the opposite of that minus that, so it's 3y squared z squared minus partial with respect to z is 3y squared z squared also. So it's the opposite of 0. And then the king component is that 2yz cubed minus partial with respect to y is also 2yz cubed. So 0, 0, 0, or the 0 vector field. So you do have a conservative vector field. So that means I can find an anti-gradient just like before. Okay, now remember the previous section that we worked with, there was a section for 3-dimensional vectors where they already told you you have a conservative vector field. But now we can prove that by finding the curl, and if the curl of f comes out to be the 0 vector, then we have a conservative vector field. So now the rest we work it out like before. That's fx, fy, fz. So fx is y squared z cubed, which means f of x, y, z, integrate with respect to x, there is no x. So x and y squared z cubed, plus possibly a function of y and z. Remember, you can have a whole bunch of junk here that has y's and z's. The derivative with respect to x is 0. So that's why you have to put that. Now I differentiate with respect to y. 2xy z cubed plus the partial with respect to y. And I set it equal to the middle component, 2xy z cubed. So if you look at this and this, that forces g sub y to be 0, which means there is no y, but I could have a function of z. So that means f of x, y, z is now x, y, z cubed plus h of z. So now I differentiate with respect to z. That gives me 3xy squared z cubed plus h prime of z. I set that equal to 3xy squared z squared. And again, that forces this to be 0. H prime has to be 0. So h of z is k. So f of x, y, z is, I can get this without messing up, x, y squared, z cubed, plus a constant, any constant at all. And you can double check. Partial with respect to x is that. Partial with respect to y is that. And the partial with respect to z is indeed that. And of course, the partial for of a derivative of any x, of any constant, is 0. Okay. Okay, 19. Is there a g on R3 such that curl g is equal to this? Okay. Well, if there were, and P, Q, and R have constant second order partials, okay, very well behaved, then we had a theorem that says div of curl g is equal to 0. But what's the div of this thing? This is the curl of g. So I want the partial of p with respect to x, plus the partial of q with respect to y, plus the partial of r with respect to z. Partial with respect to x is sine y. Partial with respect to q is negative sine y. Partial with respect to z is 1, which is 1 not equal to 0. So the answer is no. Okay, so again, the logic is if there is such a g, such that curl g is this, that means we can find an anti-curl, then the divergence of curl g is 0, but the divergence of this thing comes out to be 1, so therefore there is none. Okay, and finally 21, show that anything that looks like this is irrotational. Irrotational means curl of f is equal to the 0 vector. Okay, so curl f is ijk, partial with respect to x, y, z, f of x, g of y, h of z. And that's easy. So curl f I component is that minus that. Partial with respect to y, there is no y, so that's 0. Minus the partial with respect to z, there is no z, so that's 0. J component is the opposite of that. Partial with respect to x, there is no x. Minus the partial with respect to z, there is no z, so that's 0. And the k component is that. Partial with respect to x, there is no x. Partial with respect to y, there is no y, so 0. So you get the 0 vector. So therefore, f is irrotational. All right. So that was section 16.5 on curl and divergence.